What's up, pre-calc gang? Welcome back. It's Thursday, April 30th. Today, we're going to wrap up some polar coordinates. When I say wrap up, this is the last little bit before we take a test on Tuesday of next week. So it looks like we are going to test Tuesday on Cinco de Mayo, guys. Okay? So today we're going to be looking at polar coordinates. We're going to graph them, and we're going to do some converting. So from polar to rectangular and rectangular to polar. And everything we're going to be doing today is on Delta Math. Like I said, there's three sections. The first section is pretty simple. Let's see, I guess I'd probably zoom in on that and refocus it. Okay, guys? So let me zoom in so you can see this a little bit better. Alright, so right there, that's about it. And we'll focus. Alright, that should be a little bit better. So what we have is this 7 pi over 3. Okay, so it says plot the polar coordinate 7 and pi over 3 on the polar grid by using the yellow dot at the pole with your mouse. Now, you can't see it, but right in the middle is a yellow dot on Delta Math. And so you would grab your cursor and you'll move it to wherever you want to put this, and then drop it and hit submit, and it'll tell you if you're right or not. So how we do this, we have the 7 represents the radius length. So you'll see these concentric circles that are going around. So we have a 1, I'm going to skip 3, 5, 7. Okay, so well, I guess I might be able to get it 2, 4, and 6 in there. So the 7, okay, is going to be represented by this circle right here. I didn't trace it very well, but that's the 7-unit circle. Okay, so that would be the radius. And then the pi over 3 is the angle at which they want you to draw the radius. And so a radius of 7 is on that green circle, and the angle, pi over 3, is right here. So what you'll do is you take your yellow dot, okay, that's sitting here at the center of the graph, and you click with Delta Math, take your cursor, and you just move it out to right here. So you would pick that yellow dot up and drop it right there. That is, and you can count, I'll do it with the black marker, 1, 2, 3, 4, 5, 6, 7, and it's at pi over 3. So that's how you graph a polar coordinate that is 7 and pi over 3. So that yellow dot that's right there is where you would unclick your cursor, leave the yellow dot there on Delta Math, click submit, and it gives you your answer. Or that's how you submit your answer. Okay, so that's the first type of problem. On Delta Math, I'm going to zoom this back out. On Delta Math, these problems do have a penalty attached to it, because they're simple questions, okay? There's not a lot of math to do. Essentially, you're just clicking and clicking and clicking until you get the dot to wherever you want it to be, okay? So that's problem number 1. And remember, you guys have these help videos that at your disposal, so use them if you need them. All right, so this is where you might want your calculator, and you may also, hopefully you still have your notebook somewhere around, have your unit circle somewhere nearby, okay? All right, so when we are converting from polar to rectangular, what we have is what they call a modulus. Okay, this is the length. That's the length of the complex number. And you see the 150s in there. That's the angle that it's at, right? So that's your magnitude and direction, so to speak. How we answer these is a complex number. Okay, so our answers for the polar coordinates, polar to rectangular form, needs to be as a complex number, a plus bi, when we submit our answer. All right, so let's show you how this goes. So essentially, you're going to distribute the 6 into the parentheses, and we'll have 6 cosine 150 plus 6i sine 150. Okay, so I'm going to do this completely with the unit circle. All right, so 150 degrees, cosine, remember, is x, sine, remember, is y. So I'm going to go to 150 degrees. Here's 150. So I'll scoot, see if I can get both of these on there at the same time. There we go. So 150, the cosine is negative square root 3 over 2. So that's going to become 6 times negative square root 3 over 2. And we'll end up simplifying and calculating out what that is. And then we're going to, let's get all this on there. 6, we'll get a plus in there. I, and then what is the sine of 150? Here's 150, the sine is a half. Move this, kind of recenter the problem. All right, so now one thing about these problems is it wants you, if it's got a radical and it doesn't fully simplify, then don't turn it into a decimal. Okay, it says express in simplest radical form. So we want to make sure that we just leave the radical there. All right, so as we multiply this together, the 2 will divide into 6, and this will become negative 3 square root of 3 plus, and then half of 6i is 3i, and there is your rectangular form. Okay, so we would just go put that into our submission, submit it, and we should get a big, nice green check out of that. Okay, so once again, you're going to distribute the length of the complex number into the parentheses, allow the unit circle, good old unit circle, just hasn't gone away, has it, guys? Use the unit circle, find the cosine of 150, find the sine of 150, plug those in, simplify it down, negative 3 square root of 3 plus 3i, make sure it's in the format of a complex number, and hit submit. Okay, so that is polar to rectangular. Use your unit circle. Okay, because it wants the exact form, and your calculator may not be able to give that to you. All right, problem number 3. Third one, last one of the day. We're going reverse of that. Rectangular form to polar form. And so they give the problem to us as a complex number. So we have to figure out how long is it. Okay, we have to use the distance formula, Pythagorean theorem, to find out the distance of that. Excuse me. And then here, okay, this is where we use inverse tangent. So I'll break that up, the distance and the angle for you. 2 different problems that we have to do for this answer. And the nice thing about the way this has got it set up, it's already got cosine. It already has the plus I in there. You notice it wants it in degree, so Make sure your calculator is in degree when we're over here doing the inverse tangent, okay? All right, so distance formula, or Pythagorean theorem, be -1 squared plus 7 squared. Square root. And we want our modulus right here in exact form. So if this comes out to be a decimal, we're just going to leave it as a radical, okay? So the modulus, otherwise known as the distance, is going to be as a radical. And you see the radical symbol right here. So it gives you, it kind of sets up everything you need. So we'll go square root. All right, -1 squared plus 7 squared, and it gives us 5 square root of 2, and that's exactly what you want to put right here, 5 square root of 2. So that is the distance, otherwise known as the modulus. Okay, then we do the angle. You know what, you can't even see everything on here, so let me back this up a little bit. There we go. Now, angles, the argument, otherwise known as the angle, can be to the nearest tenth of a degree if it's necessary. So when we do our inverse tangent, if it doesn't come out to be an exact angle, then we'll round it to 1 decimal place. Inverse tangent of b, which is 7, over -1. And I have a feeling this isn't going to come out to be a whole value. So I don't know if you can see it. I'll move it over here. You can see it better. So inverse tangent, 7 divided by -1 is -81. All right, so we got a problem, right? So it gives us a -81.9. So we'll go ahead and write that down. -81.9 degrees. We can't do that. Can't have a negative value, right? Because if you look in the directions, it tells you got to have a value between 0 and 360. So where is this? So we'll quickly figure out where is this angle. All right, so if we plot this, and the number again is -1 plus 7i. So that looks like it's going to be, let's use that color. We're going to go left 1 up 7, so it's over here in the second quadrant. So that's going to give us a value from the x-axis in a negative direction, -81.9 degrees. That's not very, here we go, 81.9. So we're going to have to come from 180 degrees and take away 81.9 to get the actual angle for us for our answer. So we'll take 180 and we'll take away that answer, which is going to give us 261 degrees. Actually, that's too big. I used negative twice on that. So let me start that over. 180 take away 81.9, and that's going to be 98.1 degrees. That's the correct one right there. That 260 was too big. I used a double negative. So 98.1 degrees is going to be what they call the argument. So 98.1, 98.1. Click on the submit button, get your big green check, get your credit, and move on. Okay? So a couple things with this problem. This one took probably the most time. Modulus is the distance, so you're going to use distance formula, Pythagorean theorem, whatever you want to use. They both come out to be the same thing. Please make sure you use an exact value for that. So use the 5 and the square root of 2. Don't use a decimal. Inside these two boxes will be the same angle. So we use the inverse tangent. So it's b over a. So that's the 7 over negative 1. That gave me a negative value because in the second quadrant, tangent is negative. All students take calculus. All students take calculus. And so we had to go negative 81.9 degrees from the x-axis up this way, which is 180. Take away 81.9 gives us 98.1. We got to have an angle measure that fits the quadrant that the complex number exists. So that one was a little bit more tricky, had a little bit more work to do to it. This problem does not incur a penalty if you get it wrong, okay? So those are the three types of Delta Math problems. Oops. Those are the three types of Delta Math problems that you're going to see on the assignment. I am going to set up a quiz on Delta Math for Friday. So anything that we did that was not on Delta Math will not be on this quiz. So I think the only thing is going to be the distance and midpoint. So it's just for this week. Excuse me. So it starts on Monday, and it's Monday, Tuesday, and Thursday's assignments. And that'll be Friday. Obviously, it's optional. You guys don't have to do anything at this point. But I had to get this material in. I couldn't spend another day giving you a day to just kind of, I couldn't use a review day. I had to get 4 days worth of material in. But trying to help your grades go up for those of you that are still sitting at a grade that you want to bump. Okay? You guys have a great Thursday, and I'll talk to you soon.